All right, well, you've watched plenty of videos, but here's one more about prisms and how to find volume. All right, that's how we're going to start. It is a bit sad today realizing that I'm making this on Monday, and I'm realizing that we won't see each other in school again this year. It's kind of sad. The governor just shut everything down for the rest of the school year, so we won't be returning to good old Glen Landing. I gotta say, it's hard for me because I miss you guys, and I got into teaching so I could, teach in a classroom and build relationships with you guys. And so I'm gonna miss it, but we're gonna make the most of it. We're stronger together, so let's get rocking and rolling. And I did figure out how to set up the Google Meet so that we could have some time to meet all together each week. All right, and we'll try to figure that out. Let's get rolling with prisms. Okay, prisms. We got two bases that are parallel to each other. In this case, we have a rectangular prism. So we have that, the rectangular base down here, and it has an identical parallel base up here, and that's what makes it a prism. All right, a triangular prism would have like a triangle and then an identical triangle that's parallel to it, and then it's connected kind of like this. Or am I drawing with this? It's not too bad. But anyway, there you go. Prisms, that's a triangular prism. This is a rectangular prism, and it's all about the two bases. All right, so now we're going to talk about how to find volume. All right, and you've heard this a bunch in the couple videos. This idea of as if you can find B, which is the area of the base, then you just extend it with that third dimension of height, and you get the volume. Now here they took out the big B and replaced it with LW. What is that LW? That is the area formula for a rectangle. Why are we replacing it with the area formula of a rectangle? Because big B stands for the area of the base, and what shape is this base down here? It's a rectangle. So that's why we can also write this formula. In this case, when it's a rectangular prism, only a rectangular prism, we can write that formula as volume equals length times width times height. All right, 3 dimensions to find the three-dimensional measurement of volume. This is just explaining quickly the idea that we have the area of the base is length times width, and then we give it a height, or the number of layers that area of the base would have, and that gives us our volume. All right, let's look at a practice problem. We have the formula here written out in its other format. We could also think of it as big B times H, and big B is the area of the base. In this case, we can replace that with the area formula for a rectangle, which is length times width. Sometimes you see little b times h, base times height, for a rectangle or a parallelogram, but in this case, the book's using LW. Like the Math Antics video said, you have to be flexible with that kind of thing. You just know it's going to be the side of the rectangle times the other side of the rectangle, and then you need that third dimension of height. Well, the book has chosen to call this the base here. So the area of that base is going to be 5 times 4, which is 20, and then we give it a height of 3. All right, and you can see the calculations here to give it a volume of 60, and we always need cubic units when we're doing volume. Area would use area. When you're measuring area, you would use square units because squares are two-dimensional and area is a two-dimensional figure. And when we're measuring just a one-dimensional, when we use one-dimensional measurement like length or something, we just use regular centimeters. All right. Okay, so try this one. Try it on your own. See if you can write the formula, plug in the appropriate dimensions, and I'll do the work over on the left there. And you can check and figure out if you got it right, and if you didn't, what your mistake was. All right, let's try it. First step, write the formula. That's the general formula for a prism. but I know that it's a rectangular prism, and I know the area formula for a rectangle is LW, and this is supposed to be an H. It looks like an L. And then I'm going to multiply that by the height. All right, I'm looking back over here. I'm going to call this my base here. So that rectangle on the bottom. The length and width of that rectangle is 9.5 and 5, and then I give it a height of 3, and I use my calculator. 9.5 times 5 times 3, that gives me 142.5. 142.5, and what types of units? I need cubic units, so that's going to be cubic meters, or we could call it meters to the third power. All right, let's see if we're right. Oh, yeah. Oops, can't quite see that last little bit there. All right, but that's okay. We'll move on to the next problem. Okay, it looks like I'm right though, 142.5. So moving on, let's try another problem. Let's see what we got here. All right, our key concept here is the volume of a triangular prism. Oh, it looks like we have that same formula because it's a prism. And notice that we have a triangular top. All right, triangular base here and a parallel triangular base there. Now, don't get confused. Sometimes these triangles will be written like this. Okay, and you'll think, oh, well, the base is a rectangle here because it's kind of sitting on this rectangle. But the bases in a prism are always the matching faces, the ones that are parallel to each other and identical, or another good math word, are congruent. These congruent triangles, all right, are the bases, even though the shape is kind of sitting on its side. You think of base, it has to be sitting on the base, but no, don't get confused by that. All right. And then the height is always the length that connects the two bases. So also be careful with that. That there is the height of the prism. So let's look over here and find, okay, volume equals big B times H, where in this case, the area of the base, what are the bases? They're triangles. So we're going to replace big B with 1/2 little b times H. That is the area of this triangle right there. So we got to find that, right? Find that and then multiply that by the height of the whole prism. So there's going to be two heights in this. One's the height of the triangular base. The other's the height of the actual prism, which connects the two triangles here. All right, so that's a little bit tricky, but once you get the hang of it, you should be okay. All right, this is showing that you find the triangular base's area and then you give it a height. You do the layers, or that extended length that the Math Antics video talked about. All right, here's a great example of when a triangular prism is sitting on its side and you think, oh, well, that rectangle is the base, and you get confused and you start throwing in stuff, but that's not the base. These, we call them parallel congruent faces. Right? As soon as you have that, that tells you what the bases are. Those are the same exact shape that are extended out. All right. So that's your base. And what you're going to do is you're going to find the area of that base using 1/2 base times height. Then you're going to multiply it by this height. Okay, that's your other height. The height of the actual prism, which is that extended length we talked about in the Math Antics video. All right, so here's the general formula. Notice that big B is replaced with 1/2 base times height of the triangle. And where'd the 6 and the 8 come from? They came from this triangular base we see that there's a right angle symbol here. So when the two dimensions meet at a right angle, that means they are the base and the height. So then we have the 1/2 times 6 times the 8. Then we're going to fill in that h. That's not the h of the triangle, the height of the triangle. That's the height of the whole prism. That's the 9 right there. Okay? So can be confusing because there's two h's in the problem. There's the h in the area formula and the h of the prism. All right? But once you get the hang of it, it shouldn't be that bad. And then you plug it in and try it out. All right? Now, we're going to go down to this example. You already can see the answer there. So now you're going to pause and see if you can get the answer. All right? See if you can do that, and then I'll give you the work. Okay, let's get after it here. I'm noticing, oops, I'm going to go and find the bases, okay? I'm realizing it's a prism. Don't call it a pyramid. It doesn't start at one base and go up with triangles up to a point. This one has triangular, right, faces that are parallel and congruent, all right? So that tells us it's a prism. It's a prism. And we have to find the area of the triangular base, and then we have to multiply it by the height of the prism. So volume, oops, I'm going to do it over here. It's a lot easier. Volume equals big BH. Volume equals that big B right there is going to be 1/2 little bh. And then I'm going to bring that over here and multiply it by the height of that. So let's just focus on the triangular base. We see the right angle symbol there. It looks like the 4 and the 5 meet at a right angle. So that's my base and height of my triangular base. All right. Now we need the height that connects those two bases, that extends the base to the other base, and that's going to be 7. Now we just got to calculate, and I'm going to do it commutative property. I'm going to do 1/2 of 4 is 2, 2 times 5 is 10, 10 times 7 is 70, and that's going to give us, we're doing volume here, so that's inches cubed. There we go, exactly what we were looking for, 70 inches cubed or cubic inches. Hopefully that makes sense. It'll take some practice, but you guys can do it. All right, here's just a little bit of a, it's asking you to apply what you know. So which lunchbox holds more? So if it's talking about how much it holds inside, that's a volume concept. So that's telling you right there that you're going to be finding volume. All right, good luck with this, some practice, and you'll be awesome.